This is term 1 week 4 math. Okay, which is true about this function x5 minus 1 over x5. They want to talk about the continuity. Okay, أول شيء you need to check any fraction will be discontinuous if the denominator equals 0. Can x power 5 equal 0? Of course it can when x equals 0. So that's why you're going to say it's not continuous at x equals 0, and it's a non-removable discontinuity. Why is it non-removable? Because when you substitute 0, you get 0 minus 1 over 0, which is negative 1 over 0, which is infinity. It would be called removable if you get 0 over 0. But did we get 0 over 0? We got negative 1 over 0. Okay, so that's part A. Alright, part B, they gave you h of x is x squared plus 12x over 3x, and circle all that apply. Okay, again, let's check, is there a discontinuity? Of course there is, because 3x can equal 0. When is that true? When x is equal to 0. So it has a discontinuity at x equals 0. So what type of discontinuity? Check here. The first thing you do when you want to check discontinuity, before you substitute the value, if you substitute the value here, you're going to get 0 plus 0 over 0. So you get 0 over 0. So is this removable or non-removable? I told you if it's 0 over 0, it's removable. Okay, so you get removable discontinuity. Now they said extending the definition by of h by h of 0 equals 4 leads to a continuous function. Okay, yeah, what they're trying to say here is at 0 over 0, the function's at x equals 0, the function gets me 0 over 0. So they're saying, let's say h of 0 was equal to 4. Would that give me a continuous function? Yes, it would. Why? Because right now it's 0 over 0. You don't want 0 over 0. Now why would this one be wrong? Because to get a continuous function, you need to look at the limit before 0 and the limit after 0. How do you find the limit of this? X squared plus 12x over 3x. X squared plus 12x over 3x. If you find the limit as x approaches 0, you get 0 over 0. So obviously, do we just stop at 0 over 0? No, we're doing a limit. So what do? X out, x plus 12 over 3x, cancel x with x, okay, and you get x plus 12 over 3. Substituting now 0, you're going to get 0 plus 12 over 3. So the limit is equal to 4. That's why you say h of 0 equals 4. So how do you solve this question if it came in the exam? Okay, the first thing you check is the type of discontinuity. I told you 0 over 0, it's removable. Okay, that's the first thing you check. Type, it's removable. So how do you extend the definition? Extending the definition basically means find the limit. Okay, find the limit. How do you find the limit? I told you finding the limit in this case would get you 0 over 0. So what do? You have to factor or derive or use L'Hopital or whatever you want. So 2x plus 12 works. The derivative method, remember the derivative method? So you get 0 plus 12 over 3, which is 4. This is the derivative method, L'Hopital. Whatever you want, but the idea is you need to extend it to the limit. Alright, which of the following is true about G? Alright, is left continuous, whatever. Alright, let's check them one by one. Is left continuous at x equals 0? Left continuous means that the left limit, so x approaches a minus, is equal to f of a. Alright, this is what left continuous is. If it was right continuous, then limit as x approaches a plus is equal to f of a. Let's check here. Left continuous at x equals 0. At x equals 0, what's the value of f of 0? You substitute it into where? You substitute it into this one. So you go 0 plus 5, which is equal to 5. Then check the limit as x approaches 0 minus. Again, which one you substitute into? You substitute in this one, which is equal to 0 plus 5. Are they equal? Yes, they are. So it's left continuous. G is continuous at x equals 3. What does it mean to be continuous? That the limit as x approaches 3 minus is equal to the limit as x approaches 3 plus, which is equal to f of 3 also. These three have to be, these three conditions have to be met. So let's take a look. The limit as x approaches 3 minus, and you substitute x as 3 here. So 3 minus 5, which is negative 2. The limit as x approaches 3 plus, you substitute it here. So 2 times 3 minus 8, which is negative 2. So until now they're equal. Then f of 3, that means substitute 3 where? Here. So 2 times 3 minus 8, which is also negative 2. Negative 2, negative 2, negative 2. So that means, since they're all equal, it's continuous. Alright, the third one, let me erase a bit. Alright, G is continuous on what intervals? Type. When you have an interval when you say minus 3, 0, that means it's continuous for all intervals, so all numbers between minus 3 and 0. Is minus 3 and 0 included? No, it's not included. Why? Because we used parentheses. Parentheses means you don't include these numbers. If it was square brackets, then it means include these numbers. So let's take a look. We agreed that it's left continuous at x equals 0. So everything approaches 0 from the left will be continuous. We agreed it's continuous at x equals 3. طب نحن what do we need? Hold up. Alright, here they're saying g is continuous on minus 3, 0. We said it's left continuous at 0. So that means everything before 0 is continuous. Is there any other function before 0? Like, is there anything else? Is there any reason to be discontinuous? There should be no reason for it to be discontinuous because خلاص, before 0 it's always x plus 5. There's no switch, there's no change. And we agreed that it is left continuous at 0. But for that reason, any number before 0, the interval will be continuous. Any number before 0. Here they said minus 3, that's correct. This is a stupid question, and like it doesn't really make that much sense. But خلاص, any number. If they put minus 5, 0, it would be correct. Why? Because there's nothing that comes, there's no equation before it. That's just why. Okay. G is continuous on 0, 3. Now we said 0 with square bracket. Why is this wrong? Because 0 with square bracket means 0 is included. We said 0 is only left continuous. Because if you check 0 here, 0 minus 5, you get negative 5. If you check 0 here, you get positive 5. These aren't equal. Okay, we said it's only left continuous. Not continuous, said left continuous. So that's why including 0 is wrong. G is right continuous at x equals 0. No. How do you check that? Again, same thing I just did now. Substitute 0, you get 5 here. Substitute 0, you get negative 5 here. So no way it's continuous. So G is continuous? No way. If it's only left continuous and not right continuous, how can it be fully continuous? It can't. Okay, given this is f of x, which of the following is true about f? Type the limit as x approaches 0.4 minus is 2. How do you do that? You just substitute 0.4 into 5x and you get 2. F is continuous on the interval 0, 1. How do you check for continuity? Check for continuity at here. Where would there be a change in continuity? At 0.4. So you need to check at 0.4 is it continuous or not. This is how you, like, see, they say 0, 1. Where does 0.4 fall? It falls between these two numbers. So you need to know that this function will always be continuous. This function will always be continuous, except at the point of where it's switching graphs. If you can guarantee that at the point of where it's switching graphs it's continuous, then the whole time it's going to be continuous, and therefore on the interval it will 100% be continuous. So let's see. At 0.4, 5 times 0.4 is equal to 2. 2 times 0.4, so مش 2 times 0.4. You can't substitute 0.4 since there's no x, so the answer here will always be 2. Are these equal? Yes, they're equal. If they're equal, what does that mean? That means it's continuous here. So that means there's no jump, there's no removable, there's nothing happening. So obviously between 0 and 1 it will be continuous. And here, limit as x approaches 0.4 plus, we figured it out here. It's 2. We did it already. We substitute 0.4. Since there's no x, you can't like multiply by 0.4 or anything. So it's always just going to be 2. Then here, they say that the limits are not equal. Is that true? No. F is not defined on the interval 0, 1. Why would it not be defined? There's no reason for it not to be defined. It would only not be defined if, like I told you, there's a discontinuity. Okay? If there's a discontinuity, then it would not be defined. F is not continuous. Again, no. How is it not continuous? We said it's continuous. There's a 0.4, 0.4. They're equal. They're both equal to 2 and 2. Part B, you have, this is h of x, 2 plus x, and then 2, between 0.4, 0.4. Okay. Which of the following is true? Now, before even solving, okay, how much will you get here? 2 plus 0.4 is 2.4. Here, you're going to get always 2. Are these equal? Not equal. صح? Not equal. So, can you say it's continuous? No, it will be not continuous. You say, this is wrong because they're not equal. With 0.4 minus, we figured it out to be 2.4, so that's correct. 0.4 plus 2.4? No, 0.4 plus is 2, we said. H is not defined. Is it not defined? It is defined. Is there like any place where it's not defined? Is there any fraction for it not to be defined? It's not defined if you have مثلا 2 plus x over x plus 2. What would make this denominator 0? Negative 2. So you would say it's not defined at x equals negative 2 if it was a fraction. But here there's no fraction, so there's no way for it to be undefined. Okay? H is continuous on the interval. We said it's not continuous since these two are not equal. Okay? Alright, which of the following is true? Select two options. H is not continuous at x equals -1 because its limit does not exist. At x equals -1, does the limit not exist? Let's see. The left limit and the right limit are both approaching the same circle. Even if it's an open circle, they're still both approaching the same thing. So can you say the limit does not exist? Bala, it does exist, but this is wrong. H is not continuous because it's not defined at x equals 2. At x equals 2, isn't it not defined? Okay, there's an open circle. You check for any other shaded circles. We checked. There's no other shaded circles, so that means it's actually not defined there. H is continuous at x equals -2. Let's take a look at x equals -2. Over here, left limit and the right limit are the same. There's no open circles, so the graph is completely solid and it's continuous. H is continuous at -1. The second you see an open circle, quickly, it's not continuous. H is not continuous because it's not defined there. Let's see, at -1, is it not defined? Bala, it is defined. You see there's a shaded circle over here, so that means it is defined. This one, I'm gonna let you guys do this yourself. I'm gonna skip it because it's just limit. You can do it on your calculator if at this point you still don't know it. This came today in the periodic. Now, it would have been very helpful if you guys know this, but instead of 16, you substitute a number really close to 16. Okay, and you get the answer if you take a look. So you get 256. Okay, this is just 256. Question 6, this I'm gonna skip. It's 6 I'm also gonna skip. I think you guys all know how to do this. You're gonna get 0/0, but like I told you, you can use L'Hopital, or you can use factoring, or you can use this method here. This method here works for every single limit, okay? Like put here -3 plus, and you want to put, what's a number approaching -3 from the right? From the right, you could put -2.99, okay, and substitute it. Anyways, question 7. I'm gonna skip this. 8. We did this before. I'll do it fast. Okay, for the limit to exist, yani the left limit should be equal to the right limit. So substitute -3 here. You're gonna get k plus x. X we said is -3. Here, substitute -3, you get 4 times 9, because -3 squared is 9. 36. So اتفقنا that these have to be equal to this. So k minus 3 has to be equal to 36. So del k 39. Easy peasy. Yalla, question 9. This one also I'm gonna skip. It's really easy. Substitute 2 plus, and you substitute into which one? This one here, x squared plus 4, the second one. 2 minus, and you substitute into the first one. You get 8. X approaches 2, you just check, is 2 plus equal to 2 minus? If yes, then it's 8. It's the value of it. If they're not equal, then you would put 9, 9, 9. But they're equal, so we put 8. F of 2, you check which one I substitute f of 2 in. The first one. Why the first one? Because he said, what's the condition? X is less than or equal to 2. You need to search for the one that says less than or equal. So it's the first one. Substituting 2 will get you 8. Since these are all equal, what does that mean? It is continuous. Q10. This I'm not even gonna bother myself. Just substitute. Remember, keep your calculator in radian mode. 11. Again, I'm gonna skip this. This is really easy. How do you do it? The number here, when you see this in the exam, you take this number, you square it. Okay? Here, you get 0/0. You can just substitute 3.99 on your calculator. You'll get the answer. Here, you can substitute 2.99 on your calculator, and you'll get the answer. Or you can use L'Hopital, or you can use factoring. Whatever you want. 12. What's the maximum distance that x can be for the values for x minus 15 to be within 28 from 9? Now, a lot of people do this. They just do 28 divided by 4, and they get 7, which is fine. You can do that. But it doesn't always work. So do the rule, f of x minus L less than epsilon x minus a less than delta. F of x in this case is 4x minus 15. The limit is what? 9 less than 28. Alright, so you get 4x minus 24 less than 28. Dividing by 4, you get x minus 6 less than 7. And your target aslan is 6. So you're supposed to get x minus 6. Did we get x minus 6? Yes. So the answer is 7. Okay, again, this is repeat. How do you do this? A lot of people just do 0.08 divided by 2. That works. If you want to do it the official way, f of x minus L, very easy. Do 2x plus 11 over 3 minus 7 over 3, so plus 7 over 3 less than 0.08. This gets you 18 over 3, which is 6. So 2x plus 6 less than 0.08. Dividing now by 2, you're going to get x plus 3 less than 0.04. Perfect. This one's easy, so you just do 3 divided by 1, which is 3. This one here, you do it on your calculator. If you don't know this, the rule is 0. Now, if you want to do it on your calculator, you're going to get 0 over 0. So what do? You substitute instead of 0, you put 0.01. Let me show you. 1 minus, make sure in radians, 1 minus cos 4 times 0.01 over sine 4 times 0.01. You get 0.02, which is close to what you always round to the nearest integer if you're using this method. You get 0. Okay? But nobody teaches you this method, only I teach it to you because teachers are scared of this method. Okay? Anyways, question 15. Okay, this is really easy. When you substitute minus 1, you're going to get negative 5 over 0. Alright? Now, this is infinity. Here, you're also going to get negative 5 over 0, which is also infinity. But you need to know whether it's negative infinity or positive infinity. So this is exactly what you need to do. Alright? What you do is, they want negative 1 plus. So you're approaching negative 1 from the right. What's a number really close to negative 1? Negative 0.99. Now for the second one, they want negative 1 minus. So you're approaching negative 1 from the left. So what's a number really close to negative 1? Negative 1.01. So to know the sign of infinity, you just substitute the number really close to negative 1 and see what sign you get. So let's see, negative 1 plus, we'll substitute negative 0.99. So let's do it. 5 times negative 0.99 over x plus 1, so negative 0.99 plus 1. You get negative 495. So what sign is infinity going to be? Negative. That's exactly how you do it. Second one, we said we'll substitute negative 1.01. So let's go. 5 times negative 1.01 divided by negative 1.01 plus 1. You get 505. This is a positive number, so we're going to take the infinity to be positive. Therefore, the limit does not exist. Why does it not exist? Because the left limit and right limit are different, so the limit does not exist. So always for this type of question, if you ever get infinity in a limit, and you need to know, if you ever get infinity in limit, you need to add the extra step. You can't just put infinity. You need to add taking the extra step of figuring out the sign. And to do that, you do exactly what I did now. Taking a number closer to the number. Question 16. What's the limit as x approaches infinity of this here? If you have a rational polynomial, okay, rational function, polynomial over polynomial, and you're examining the limit as it approaches infinity, you only consider, it's written here, so I'm not going to write it, compare only the highest powers. So up here, the highest power is 12x squared. Down here, the highest power is 3x squared. Now you substitute your infinity, so 12 infinity squared over 3 infinity squared. Infinity squared, infinity squared, you're left with 12 over 3, so you're left with 4. Okay, question 17, they gave you this function, and then they're asking, find the left limit here. Find what's the left limit? They want right limit, not left limit. The limit as x approaches 1 plus. So we go to 1 and we approach it from the right. What y value are we approaching? 24. Now, as you can see, this is an open circle. So they're asking for h to have a limit at x equals 1. We must have limit as x approaches 1 plus of h of x. Sorry, I didn't read the top of the question. Okay, this one is chill. Okay, but here they said consider the function. I didn't read this part. Consider the function defined over the set of real numbers by h of x is this 2x plus k for x less than 1, and then for x greater than 1 it's f of x. So now what did they draw for us? They only drew the graph for us after 1. So what are they drawing for us? Only f of x. Okay, so the first question was nice and easy, 24. Then they said for h to have a limit at x equals 1, we must have the limit x approaches 1 plus h of x to be equal to 24. This is really straightforward. We just did it here. X approaches 1 plus gets you 24. So okay, what's the value gonna be here? Really easy. So that means over here, the 2x plus k should be equal to what also? 24, if we want a limit. We're talking about x1. So what do we substitute x as? 1. So 1 plus k equals 24. So you get 2 plus k equals 24, which yields the result of k equals 22. Alright, question 18. Consider these function. You have piecewise sine 12x over 3x when x is not equal to 0. Then at 0, it's b. Where b is a whole number. What's the value of b that makes g of x continuous over the set of real numbers? So for it to be continuous, the value here must be equal to the value here. So what's the limit of this as it equals 0? 12 divided by 3 is what? 4. So this b has to be equal to 4. That's it. You can do it in your head. Then last question for the day. X squared minus 36 over x minus 6. And then you have m. For what value is it continuous? Again, same thing. You need to check the limit as x approaches 6. Here. Akid, you're gonna get 0 over 0. So what you do, you can derive. And you're gonna get 2 times 6 equals 12. Or you can use factoring, or you can use whatever you want. I don't care. But you're gonna get 12 as the limit. So obviously this m here has to be equal to 12. هيك بنكون خلصنا. Thank you so much for watching and good luck in your exam.